Alright, we are about to start day 4 of our series of lessons on absolute value and piecewise functions. By now, you should all have this lesson in your hands. So if you don't have this lesson, make sure you get one. Also, you should have turned in your homework by now. So if you have not turned in your homework yet, put your homework in the tray right now. Make sure at the end of class, make sure you don't leave without tonight's homework, which you will be given by the sub. Now, let's go ahead and get started. We learned how to graph absolute value functions. So let's just review that quickly. Looking at problem number 1. One way to do it is to start with the vertex. Okay, Margaret, look at this function. What is going to be the vertex of this function? Well, obviously I don't know if Margaret actually said anything, but looking at this x value, see how there's nothing with the x? Class, that means the x value is 0. And looking at this number on the end, the plus 1, that means the y value is 1. So, the vertex is 0, 1. So I can go ahead and graph the vertex. So there's 0, there's 1, so my first dot is going to be right there. I feel like I should zoom in more. Now that I've got the vertex, it's time to decide how to make additional points from here. Irvine, how will I make additional points from here? Or Siobhan, if this is third period. Or Clara, if this is 7th period. How do I make additional points from here? Well, I'm hoping you said that I will go up 1, right 1, because that's the invisible slope. So up 1, right 1 will be like this. That will give me the right-hand branch. Absolute value is always what kind of shape, Edgar, Kiera, Jessica? Always a V. So I'm going to get the left-hand side by doing the reflection and making it a V. Okay, so that is what this absolute value function should look like. Of course, we can go ahead and connect those dots if we like this. Okay. Anything else I'm supposed to do with that? Alright, let's look at the second one. Okay, looking at this graph right here, I need to hear from either Jessica, Maurice, or Kiera, depending on the period. Please tell me the vertex of this function. Vertex. I'm hoping that you said -2, comma, -3. Remember, it's always the opposite of this one, comma, this one. That's how you do the vertex. So that vertex is at -2, -3. So that's going to be like here, -2, -3. There's my vertex. Now, how will I get more points from here? Greder, Christy, Graham? How will I get additional points? Well, yeah, just like the last one. There's no slope visible, so that means it's the invisible up 1, right 1, starting from the vertex. So up 1, right 1 from here would be like this. Just make a bunch of points. Okay, always a V, so let's reflect it. Absolute value functions always make this V shape. So this function is going to look like this. Okay. Alright, looking at graph number 1, what is the axis of symmetry? Now, the axis of symmetry is the line that's going to split this V right down the middle, a vertical line through the vertex. You know what? You cannot really see that very well. So I should pick a different color. Let's just go for red. This is the axis of symmetry. Okay, it's a vertical line at 0. Now, how do we name a vertical line, class? Can you give me the equation of this vertical line? Go. Is it x equals or y equals? Okay, I hope somebody said x equals. This is a vertical line at 0. Vertical lines are always x equals. In this case, x equals 0. That's the axis of symmetry for graph number 1. Now, let's do each piece of this graph separately. Maybe I should color these. I'm going to make one part of this graph green. Okay, I'm going to let one part be green, let the other part stay red. Alright, we are supposed to write the equation of each piece of this V. Okay, find the slope and y-intercept of each piece. Okay, so dealing with the red piece on the left, the slope, let's see, the slope is, well, it's down 1, right 1. So that means the slope is negative 1. Now, how about the y-intercept? It seems to hit the y-axis here at positive 1. Okay, so the y-intercept is 1. Now, let's do the green side. Well, this is up 1, right 1. So this slope is positive 1. Well, guess what, you guys? The slopes of the two sides will always be the same, except for one is negative and one is positive. So just keep that in the back of your mind. The y-intercept, in this case, it's the same thing for both lines. The y-intercept is positive 1. Okay, so we did that. Looking at each of these pieces of the absolute value function, write a piecewise function. Now, remember what a piecewise function looks like. It starts off with f of x, like this, and then it's got this kind of a bracket thing happening, and we're going to write each of the pieces. Let's work left to right. That's what I like to do. And I'm going to keep matching the colors. So let's do the left branch, the branch that's in red. The slope and the y-intercept, negative 1 and 1. Think y equals mx plus b. The equation for this part of the branch, looking at the line, is going to be y equals negative x plus 1. There's my slope, and there's my y-intercept, so negative x plus 1. Well, putting that into the function, I will write negative x plus 1. Now let's do the same thing for the green part. The green part, if I were to write the equation for that, that would be y equals positive x plus 1. So let's go ahead and include that in the piecewise function. Positive x plus 1. Now, for the piecewise function, we need this if x is less than, if x is greater than. The part that tells me where one piece stops and the other piece begins. So, the axis of symmetry. The reason why I had you write the axis of symmetry, x equals 0, because that value of 0 is where one piece stops and the other piece begins. That's the point where everything changes. So that means when I do this function, it's going to involve 0 as the cutoff point for both lines. So it's going to be like this. If x is something 0. Now, so it's either going to be less than or greater than. So look, let's see. This red part is the left side of a line. That's why I'm going to say x is less than 0. Now I could have said or equal to, because you really can't tell whether it's should be open or closed. Just do one of each. Let one of these be less than and the other one be or equal to. It really doesn't matter which. But let's go ahead and do the green side of the line now. Okay, same cutoff, but this time it's going to be to the right. So it begins at x value 0, but it goes to the right. So I'm going to say if x is greater than or equal to 0. Bam! There's my piecewise function. Okay, let's turn our attention to graph number 2. Again, let's look at the left and the right, the red and the green. I always like to work from left to right, so let's just stick with that. Let's go ahead and note what the axis of symmetry is. So here's the vertical line going through the vertex. So this is my axis of symmetry doing something like this. Okay, so that is a vertical line at -2. That means x equals -2 is the axis of symmetry. Remember, that's important because that's going to be where one piece stops and the other piece begins. So that's going to be my if x is less than -2, if x is greater than or equal to -2. That's going to be what I'm going to have at the end of my piecewise function. Now let's talk slope and y-intercept. For the red part, the slope is going down 1, right 1. So, okay, do you guys know that m represents the slope? Okay, so the slope here is -1. Okay, the y-intercept, well, we have to be a little bit careful, don't we? Because this piece doesn't actually touch the y-axis. So if we want to know what the y-axis is, we have to continue the line, sort of extend it and see where it crosses over the y-axis. So when I make these extra dots, I can now see. Let's see. It's time for me to call on, let's see, Maritza, Ashlyn, Roshana. What is the y-intercept of the red part of the graph? Maritza, Ashlyn, or Roshana? Maybe you are counting right now. It goes down 1, right 1. You can see that this is the spot right here where it would touch the y-axis. That is down 1, 2, 3, 4, 5. So the y-intercept is -5. Let's go ahead and write that into an equation. The equation for this would then be y equals -x minus 5. Y equals -x minus 5. Now let's do the same thing on the green side. On the green side, I have a slope. A slope of, well, it's going up 1, right 1. So that's a slope of 1. I have a y-intercept. Well, this one, I can just see the y-intercept is right here. So I have a y-intercept of -1. So if I made an equation out of that, it would be like this. Y equals positive x, there's my slope, minus 1, there's my y-intercept. Okay, these are the things that I will use to write my piecewise function. The red equation, the green equation, split by my axis of symmetry at -2. So keep in the back of your mind, it'll be the red equation when x is less than or equal to -2, because it's the left side. It'll be the green equation when x is greater than or equal to -2, because that is the right hand side. So let's see what we've got. So I'm just going to skip straight to writing of the piecewise function. So you know what, let me start off in purple, a nice neutral color. So f of x equals, let's get started. So the leftmost function, the red one, believe it was -x minus 5. If x is less than, I'm forgetting what it looked like. Let's see, -x minus 5, oh yeah, -2. Remember, the axis of symmetry is the cutoff. So to the left of -2 is where the red graph is. So less than -2. Now let's do the green graph. The green part of the graph will involve the equation, come on, do it. The green part of the graph will involve x minus 1, and it will be greater than or equal to -2. Okay, so here we go, x minus 1. If x is greater than or equal to -2. So you can see that an absolute value function, the v of it, you can also view it as a piecewise function. Each branch of the v can be viewed as a piece of a piecewise function. So that's why we're learning about both of those things in the same unit. Okay. Graph each function and rewrite it as a piecewise function, separating the domains at the axis of symmetry. So basically, now it's time for you to try on your own. So, go ahead and pause the video for a couple of minutes. And when it seems like most people are finished, we'll restart the video. We're just talking about number 3. Just try to do number 3 at on your own while the video is paused. Go ahead and pause the video now. Okay, hopefully the video got paused long enough for you to do problem number 3. So I'm just going to go through it relatively quickly, because you should just be checking your work right now. So when you graphed problem number 3, your first step should have been to figure out what the vertex was. Okay, the vertex for number 3 should be 0, 9. That's the vertex. There's nothing in there with the x. That's why it's just a 0. Then the plus 9. That's why it's 9. So let's see. 0, 9. That's going to be, I'm pretty sure this is 9. It's going to be right there. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So there's my 0, 9. Now, it's time to do the slope. Be careful. This time the slope is -2. That's like having -2 over 1. Okay, so that's going to be down 1, right 1. I should do this part in green. There's my vertex. So down 1, right 1. No. I'm sorry. The slope is -2. So that's down 2, right 1. So down 2, right 1. Down 2, right 1. Repeat, 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 repeat. That's a lot of dots. That gives us the right branch. I'll go ahead and color that in. So remember that was down 2, right 1. Okay, now I will do the red branch. It should be the mirror image of this one, so it should be down to left 1. Down to left 1. Repeat, 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 repeat. So you can see where the left branch of the V is going to be. I'm going to draw that in. Okay, now we have drawn the absolute value function. Now, the axis of symmetry is the y-axis. You can probably see. Alright, this is the axis of symmetry. This is the place where one branch stops and the other branch begins. So, the line x equals 0 is the axis of symmetry. So let's go ahead and write the red equation. Okay, so if I were to write an equation for the red, y equals, well, the slope of the red part, this is up to right 1. It's a positive slope. It's uphill. So that's 2x. Of course, the y-intercept is 9. So 2x plus 9. Okay? So that's going to be one part of my piecewise function. Now, the green side over here. This side has a negative slope. So instead of a positive 2, this side has a slope of negative 2. Negative 2x plus 9. Same y-intercept. That won't always be the case, but since the vertex is on the y-axis, the y-intercepts are the same. So I have my two pieces. I have my axis of symmetry showing me where one piece stops and the other piece begins. I am ready to write my piecewise function. Okay, let's start off with a nice neutral purple. So f of x equals squiggly bracket. Alright, I always like to do from left to right. Just follow my lead. Use my good habits. So the left line has the equation 2x plus 9. So I'm going to go ahead and put 2x plus 9 first. If x is less than 0. I'm talking about 0 because that's the breaking point. That's the axis of symmetry where everything changes. I put less than because this part is to the left of 0. Now let's do the green part. Negative 2x plus 9 to the right of 0. So negative 2x plus 9 if x is greater than or equal to 0. Now if you didn't catch it earlier, you might be sitting there thinking, well, wait a minute. He made the first one less than, but he made the second one greater than or equal to. Why is one equal to and one's not? Looking at the V, they look the same. There's no open circles, there are no closed circles, it's just a V. How do I know which one to make less than and which one to make or equal to? Well, I'm hoping somebody that was paying attention right at the beginning of class shouted out, it doesn't matter. You need to just pick one. Don't make them both the same. Make one of them be less than and make the other one be or equal to. Either one will be correct. I always just let the first one be less than and the second one be or equal to. Okay, so that is number 3. Go ahead and pause the video for about 3 minutes and give everyone a chance to do problem number 4. Pause the video now. Okay, well, I hope that you paused the video and you now had a few minutes to get problem number 4 done. So now I can speed through it and you're just checking your answers. Let's see how fast I can do this. Let's start with the vertex. The vertex of this function is going to be, you know what, let me call on somebody. I need to hear from either Jesus, McDonald, or Brooke, depending on the period. What is the vertex of this function? Jesus, McDonald, or Brooke? Alright, hopefully that was enough time for you to answer the question. Looking on the inside of this function tells me the x-coordinate. That x-coordinate is going to be, class, -2. It's always the opposite of this one. Since there is nothing going on the outside of the function, that tells me that the y-coordinate is, class, 0. So there's my vertex, -2, 0. So that's going to be right about here. See, -2, 0. It's going to be sitting right on the x-axis. Okay. That means when I do the left side of my function, well, let me not do it like that. Okay, so starting from there, now I will use the slope to get additional points. Really, this will be the right-hand side of the function. So 3/2 is the slope, so I will go up 3, right 2 repeatedly. Up 3, right 2, up 3, right 2. That will give me the right-hand side of this V. Okay? Then I will reflect, get the mirror image. So I will have to do up 3, left 2, up 3, left 2, up 3, left 2. That gives me the left-hand side of the V, like this. Okay, now I've graphed it. Now let's do the equations for each one of these. So for the red one, maybe I'll pull this down a bit. For the red one, I've got y equals, I need the slope. Is this a positive slope or a negative slope, class? This is a negative slope. See how it's going downhill? Down 3, right 2. So -3/2. That's the slope of the red one. X. What's the y-intercept going to be? Everybody think about what the y-intercept is going to be. But I need to hear from Kelvin, Marcos, or Braxton, depending on the period. Kelvin, Marcos, or Braxton, what will be the y-intercept of the red graph? Alright, hopefully I left you enough time to figure it out. Remember, the red part of the graph clearly doesn't touch the y-axis. So if I want to see the y-intercept, I need to extend the line with extra dots. This graph is going down 3, right 2, down 3, right 2. Let me continue that pattern. So down 3, right 2, ba-bam! Right there. Down 3, right 2, down 3, right 2. So you can see that this is going to be my y-intercept right here at -3. So I am really hoping that Kelvin, Marcos, or Braxton said -3. So that is my red equation. Now let's do the blue equation. Okay, for the blue equation, I'm going to have y equals. I don't have to think about the slope too hard. It's going to be the same as the red slope, only positive. They are always going to be the same but opposite when it's a V like this. So positive 3/2x. The y-intercept is a little obvious. Class, blurt out, what is the y-intercept? It's going to be 3. It's right here. It's where it touches the axis. So 3/2x plus 3. These are the two equations I have to deal with. Let's talk axis of symmetry, you guys. Axis of symmetry. What's up? I think we'll go green on this one. The axis of symmetry here's the V right down the middle of it. So this green line is my axis of symmetry. Okay, that is x equals -2. That's important because that's where one branch stops and the other branch begins. So it'll be red to the left of -2. X is less than -2. It'll be blue to the right of -2. X is greater than or equal to -2. Let's pull it all together. Okay, so here we go. F of x equals, just getting it all set up. Let's work left to right as I like to do. Let's do the red one first. Okay, so let's start with the red equation. -3/2x minus 3. So here I go. -3/2x minus 3. Remember, the axis of symmetry is here at -2. So I'm going to say if x is less than -2. It's all about the axis of symmetry. That's the cutoff point. Now, let's see, what was that other equation, guys? Okay, the blue one is this, 3/2x plus 3. So here we go, 3/2x plus 3. If x is greater than or equal to -2. Boom, that is how you do that. That is the end for number 4. Okay, let's see what's next. Alright, pause the tape for 2 minutes. Try to do number 5 on your own. Okay. It is I, your boss. Just kidding. I'm watching too many commercials. Hope you had time to do number 5. Hope you had time to pause and then do number 5, and now you've restarted. Because I'm rolling on. Let's start with the vertex of problem number 5. Vertex. Let's see. It's time for me to pick on India. John. Or John. Ha! I have Johns in every class. Let's see. What John am I talking about? In period 7, that's Ocella. Hollison. That's right. Hollison, Ocella, or India. That's who I'm talking to right now. What's the vertex of number 5, guys? Yes! At least one of the 3 of you certainly got that right just now. Hopefully you said +6, comma 2. Right? India, John, and John. It's always the opposite of this one, comma that one. So +6, comma 2. Let's go ahead and graph that. 6, comma, so 1, 2, 3, 4, 5, 6, 1, 2. There's my vertex, you guys. Check it. Now, for additional points, I will go up 1 over 2 because of the slope right here. So up 1, right 2, up 1, right 2. I ran out of space on the graph. That's okay, that's enough. That's enough. So that gives me the right-hand branch of this V. Of course, I will switch to red and do the left-hand branch now. Left-hand branch should be up 1, left 2. So it would be like this. Repeat, repeat, repeat. Okay. So this one's going to look like this, you guys. Okay, let's go ahead and get the equation for this left part over here. Let's see, Miss Street in period 1. What will be the equation of this red line? In other classes, anybody can just jump in. I'm going to have y equals. Let's start with the slope. What is the slope of this red line, class? Is it positive or negative? Yeah, hint, hint. It's going downhill. It's going down 1, right 2, down 1, right 2. So that's negative 1/2 x. Miss Street, or anybody else, what is going to be the y-intercept? It's kind of hard to see because I missed the point, but it was right there, wasn't it? Bam, bam, bam. Yeah. What is that? 1, 2, 3, 4, 5. So that's negative 1/2 x plus 5. Okay? So that is going to be the equation of the red line. Now, Irvine, Siobhan, or Clara, talk to me about the equation of the blue line. What's up? Irvine, Siobhan, or Clara. Here we go. Y equals. What is the slope of the blue line going to be, Irvine, Siobhan, Clara? Yeah, hopefully you pretty quickly said 1/2. Alright, if the other one is negative 1/2, this one will be positive 1/2. It always works out that way. So positive 1/2 x. Now, Margaret, Edgar, Kiera, I need to know the y-intercept of this blue line. I'll give you a few seconds to figure it out, but I want to hear from Margaret, Edgar, or Kiera, depending on the period. Let's see what you guys came up with. Hopefully you understood that I need to extend this line to see what's happening. If I go down 1, back 2 repeatedly, down 1, back 2, down 1, back 2, down 1, back 2, ba-bam! Down 1, back 2, down 1, back 2. Well, here, this is the point right here. Okay? I'm hoping you can see that the y-intercept is this guy. So that's negative 1. So hopefully somebody had said negative 1. So 1/2 x minus 1 completes that equation. Okay. Greder, Christie, or Graham, I need to know the axis of symmetry of this picture. What is the axis of symmetry? Well, remember that the axis of symmetry is the vertical line that splits this right down the middle. Okay, so axis of symmetry, we're talking about x equals 1, 2, 3, 4, 5, 6. X equals 6. Remember, that's important because that's where the red line stops and the blue line begins. That's going to be my little x is less than 6, x is greater than or equal to 6. That's why the axis of symmetry is important. Okay, now let's make our function. Okay, here we go. F of x equals, make the brackets. Here we go. Let's start with the red. I like to work left to right. Be like me. Negative 1/2 x plus 5. So negative 1/2 x plus 5. Maritza, Ashlyn, or Roshana, what am I about to add on to the end of this red line? What comes next? Okay, hopefully you guys said I need to add on the part that says if x is less than 6. Using my axis of symmetry, like I just described, to the left of 6, so if x is less than 6. Now let's do the blue part. 1/2 x minus 1. So here I go. 1/2 x minus 1. Alright, think about what's coming next. Jesus, McDonald, or Brooke. I need to know what's coming next. Go ahead and tell me what's coming next. Jesus, McDonald, or Brooke. Alright, hopefully somebody somewhere said if x is greater than or equal to 6. Because it's going to be the blue graph. Everything changes at 6, but the blue graph is to the right, so that's greater than or equal to. Okay? Let's see. Miss Street, how do I know when to use the or equal to and when to just leave it less than? How do I know? It doesn't matter. Just let one be one and let one be the other. It doesn't matter. Okay, at this point, some of you are running out of time and class is about to be over. But you just make sure that you get your homework. Alright, nobody leave the class without getting your homework. Some classes are full length, so you may have time to watch the rest of this video, but regardless of what class you're in, even if there's not enough time to finish this lesson, do not leave the room without your homework from the sub. Okay, if class is still running because you have a full length class, go ahead and pause the video right now and give everyone a chance to do number 6 on their own. Alright. Do you have anything to say, my daughter?
No, I'm just listening. I'm just playing games and listening to you teach the lesson. You're very educational.
Alright. Do you care that I just put your voice in this video just now?
You did?
Yeah. I didn't stop. I didn't pause.
Oh. Okay.
Alright. Hopefully, everybody had time to work on the problem. Then the video was paused and then restarted, and now you've already done number 6. Because I'm going to act like that's what happened. Okay, let's see. Who is it time for me to pick on? Kelvin, Marcos, and Braxton. I need to know the vertex of this problem. Vertex. Again, Kelvin, Marcos, or Braxton, look at this and tell me the vertex right now. Go. Okay, I'm hoping all 3 of you said -1, comma, -2. Because it has to be the opposite of this one, comma, that one. So let's go ahead and graph that. -1, comma, -2 is going to be right here. I will get additional points using the slope. This -3 means down 3, right 1. So I will go down 3, right 1. Down 3, right 1. Okay, so that's going to be like this. Down 3. Wow, I missed. Let me try that again. In fact, maybe I shall cheat a little bit. Daddy, no. Well, it's not really cheating, is it? I'm using the technology. Okay, down 3, right 1. What am I doing? Blue? I can do that. I can make that happen, yo. Okay, pretty good. So that's that one. Now let's do the left-hand branch by reflecting. So I will go down 3, left 1. And repeat, and that's all there's space for. I'm just going to go ahead and cheat again. Down 3, left 1. So it's going to be like this. And what's this one? Red. I can swing that. Okay, so we've got that going on. Okay, let's go ahead and label up the pieces with some equations. Starting with this one. It is time for me to pick on. Who's it time for me to pick on? India and John. Give me the equation of the red line. You can give it to me in pieces, sure. Let's start off easy. Y equals. What is the slope of the red line, India, John? Well, it's positive, and it's up 3 over 1, so that's going to be 3. So that starts me off with y equals 3x. Okay, Irvine, Siobhan, and Clara. I need to know the y-intercept of the red line. Now, I'm going to give you 15 whole seconds, but I want to hear from Irvine, Siobhan, or Clara about the y-intercept of the red line. Go. Okay, did I say I was going to give you 15 seconds? I fibbed a little bit. Okay. Hopefully you said the answer already. This is going up 3. To see where the red line would cross, I need to extend the line. The slope is up 3 over 1. So if I continued that, it would go ba-bam! And then it could continue up 3 over 1, up 3 over 1. I said ba-bam right here because that is the y-intercept. So that's why I'm going to put a plus 1 on the end of this. So I've got that equation. Take that to the bank. Lock it in. Now, let's do the other part. The blue part. Y equals, let's see. I need to talk to Margaret or Edgar or somebody else in 7th period. Let's see. What is the slope of this blue line? Margaret, Edgar, or somebody? Yeah, well, if this one's positive 3, you know this one's going to be negative 3. So that's going to be negative 3x. What's the y-intercept of this blue one, class? Obviously. Y-intercept? It's negative 5. It's right there. So negative 3x minus 5. Brilliant. Just brilliant. So it's time to go ahead and make the equation, the piecewise function. So f of x equals squiggly bracket. Let's do the red one. Okay, the red one's going to be 3x plus 1. Let's get the blue one. The blue one's going to be negative 3x minus 5. Whoa, you know what we didn't do yet? The if part. The axis of symmetry. We better do that right now, yeah? Okay, the axis of symmetry is right here. Okay, here's my axis of symmetry. I think I'll make it orange. Okay, there's my axis of symmetry. What is the value of that axis of symmetry, guys? Yeah, that's x equals -1. So keep that in mind. X equals -1. That's going to be my less than -1, greater than or equal to -1. Do you have anything to add, daughter? We are recording.
Math is awesome!
Yay!
Yay!
So on the end, I'm going to add in if, let's see, what am I going to add in on the end here, class? If x is less than -1, because it's to the left of -1. What about the blue one? If x is what? Greater than or equal to -1. Class, how do I know which one to make or equal to and which one to leave plain less than? It just doesn't matter. You pick which one you want it to be. Okay, that is it for the lesson. We are out of time. Make sure that you do not leave class without your homework.